Welcome back. I am going to do now some actual training on soldering. I've already explained what type of equipment you might want, budget ranges, all that sort of stuff. But right now I'm going to actually go through some soldering skills that you might want to learn how to do. To begin with, beware, this stuff is hot. So if you splatter solder on yourself, you'll burn yourself. So be careful. Don't wave your pencil around with solder dripping off the end. Be careful when you solder components because the solder points will be initially hot to touch, so you can burn your fingers. So to begin with, a couple of things you have to remember. The tip of your pencil should always be nice and shiny. So I use the brass wool to keep my pencil clean. Like so. And you can see my pencil tip is fairly shiny. Now if the autofocus of the camera would work, we'd all be in business, but it doesn't do a very good job. Now this I use for tinning, but you don't have to do this. This stuff does not contain resin, or rosin if you wish to say it that way. All it is tin. That's all it does. As you can see, that's all it does, is tip. Tinning the tip of your pencil is always to be done. Like, it's a gimme. If you don't do that, right, your tip will get corroded and you'll waste the tip and you'll have to replace it eventually. Our next thing is solder. Now, there's a couple of ways of doing this. I just take a section of solder off my roll. Voila, that's what I do. Now, solder, as I said before, comes in different diameters. This happens to be 0.8 millimeter solder, I believe. If I bring out my little solder holding device, it's not light because it's 2.5 kilos of solder, so it's like a kilo of weight. So this thing right here. So if we look, we just move the handle, we can see 0.8 millimeters, and this company is out of China, and this, if you look up a 63A, what you'll find, and this is hard to read on this, see the focus there, see that SN55A? So it's 55% one metal and 45% another metal, i.e. lead and tin. 65 lead, 45 tin, or 55 or whatever. But basically, it's a variant in the 60-40 lead solder. Now I actually have, as I shown before, Kester's roll of solder. Two types. This guy here is, if I turn it around so I can actually read it, this is SN60 PB40. So this is true 60-40 solder. It is 0.75 millimeter. And this solder, which is also Kester, you can see it's 6337. Let me just see if I can get the focus again. Wow. This is just ridiculous with this focus crap. Where's my VL feed? Let's take the focus off. There we go. Manual focus. So you see CN63PV37, but you also notice that this is 50 instead of 75 or 80. It's pretty fine solder. So I don't use this stuff too often because it's pretty thin. This stuff is more like what I want to use. Now I have, after using the Chinese solder, I have discovered a bit of a difference between them. So this here is 0.75, and this blue roll here is 0.8. I find this roll here liquefies better. Like when I'm using it, it flows better than this stuff on the blue roll. Now, I don't know if it's a combination of thickness and or this being 55, 45 type idea. So, but it works. I mean, don't discount it. It will work just fine. Now, the green roll that was on the bottom of that rack is actually lead-free. Now you'll hear, "Oh, lead-free! Oh, don't use it!" Okay, really, the stuff works just fine. Also, it's up to you. I find I have to have my pencil at a slightly different temperature for lead-free than leaded solder. That's about all I've found. Otherwise, it works just fine. So different components have different tolerances to heat. So I have here electrolytic capacitor. I have here a ceramic capacitor. I have here a standard resistor. And I will go upstairs and I'll get some other parts that I have. So in here, let's pull one out. So I can get my fingers in there. We have a transistor, what they call a TO92, I believe. We have, these are potentiometers. They use a little screwdriver and voila. There are also LEDs. Except I can't seem to get this one open. I don't think I've actually opened this container yet. So I find there's some Scotch tape still on it. So here we go. So here we have LEDs of various colors. I'll just take a blue one out. In various diameters. So that's a really big one. And that's a tinier one. We also have, and I used one in a previous video. I'll just take one out. These are all dip sockets for chips, various lengths. So here's a little 8-pin. These are power regulators. Let me get one out. Now, these come basically, you can see on the label in here, there are 78s. In this particular box, they're all 78s. Oh, there we go. I have another box which actually has 79s in it. So 78s 78s of these things are positive voltages, and 79s are negative voltages. So when you see this particular part, which you believe is a 7812, so this regulates for 12 volts out, and it's positive. So you can also get a 7912, and it'll be negative. Now these are all various types. Now parts like this, the capacitors, they're not too bad. You can heat them up pretty good and they still will work just fine. The ones that are really vulnerable to heat are these guys, the TO92s. And these guys, the LEDs. And any time you put one of these plastic little fixtures in here, these little, for example, these little dip sockets, or pin headers or anything like that, if you heat the metal pin up too much, the pin can actually come out of the plastic. Or when you're doing the pin, you can actually push the pin back through, especially on pin headers. So in this little container we have pin headers. Okay, so let's see if I can find a short row here. Yeah, so you can see by shipping some people have damaged the pin here. Yeah, see, they're fragile. You don't want to bend them. I like these little round ones because when you put your cutters here, you can split them easy. So I'm going to make a 4 off here. So I've created a 4, like so. Now I have the other type in here, and these are really vulnerable to overheating. These guys will push their pin right through if you're not careful. I mean, literally, you're transferring heat through a metal and it conducts heat very, very well. So let's take a 4 off on here too. Now, there are flat ones like this. This is a flat edged one. See how the holes are not that round effect? These are practically impossible to cut easily. I haven't figured out a way of doing this without probably a Dremel tool or something like that to cut it really nicely. If I cut it with the side cutters, it'll just crack them. Now there are some other parts that are also vulnerable to heat. So we have LED matrix displays and digits here. These aren't too bad, right? You can usually do these fairly easy. It's on this foam that I have the bad ones. So here we have ICs right there. Right, we have some crystals. Relays, no, not too bad. More digits, right? If you have to, when you're dealing with this sort of stuff here, like this one here, I've already put it into a socket. So you solder the socket on and then put the chip in. That's probably the safest way of dealing with these, because any direct soldering of these things will cause problems. And here's a whole bunch of other chips. And believe it or not, these are all op amps. So 555 timers, that sort of thing. Logic, this is all logic. These are all CPUs. Okay? But basically, if you want to play it safe with any of this stuff, socket first, put these in the socket. You'll find the first time for a while when you do soldering, you tend to have the pencil on too long. So I'm not going to waste any of those. So I'm going to use this little board here, and we're just going to solder some stuff to it at random, just to see how to do things. Now, I have some accessory tools that I keep around. Of course, cutters for cutting leads off. Those are important. Okay, and I also have Where did I stick it? Let me just find it again. My pokey tool with the little right angle thing on here. This is great if you have to pry up a chip or just poke at something or whatever. This is very handy. Now, I find my eyesight's not good, so usually when I'm soldering on the mat here, I have to bring it high up. And when you're soldering, you don't put lots of solder on your pencil and then put it on the wire. That's the wrong way to do it. You put the soldering tip on one side of the wire or lead like this, right? And you apply the solder to the other side and you let it flow. Now, some boards you'll find, this is not one of them, are what they call plated through holes. So not only on the top, but on the bottom. So let's see if I have. I'm going to just look at one of these Arduino here units. So where's my little knife? Of course, I don't have my knife. Now, the other thing is the surface you're going to solder on. You don't want it melting. So I would invest in something like this. This mat, I got it off Amazon. It's actually rated at a very high Celsius before it actually melts. So if you put your tip on here, nothing much happens to it. So if you splatter solder on here, right, like that, you're not going to damage things. And it acts as a cutting board. So see, no cuts. So let's take out our parts here. More of these edge connectors. So when we look at this, now let me just change the focus manually on this because I know this does it stupidly. Notice that these, if you can see it, are through-hole solder pads. You can actually see the tinning going right through the holes. There, see at the angle, you can just see it. So on both sides of this. So the idea is that when you solder something in here, let's say we're doing the bottom piece right here, like so, that you just don't want to solder the tip like this, all these pins, but you want to let the solder flow through the hole so it's fully connected correctly. So we're going to do this later. And I'm just going to turn the autofocus back on again so we can see the mat. There we go. Always keep a clean bench. There's nothing worse than having a sloppy mess. I also save these static little anti-static bags. They're useful if you have to store parts or anything like this. So I have some leftover solder here. I'll use it up. But I'm going to cut myself another strip off here. Now, all I usually do is just wrap it around my finger a couple of times so that I have a piece like this that I can hold. Now, it is important that the smoke that comes off solder is not leads, it's not tin, it's the rosin in the solder burning. So when you take your pencil like this, and if you were tinning, this is why I like the other tinning type, but if I was to be tinning with all that smoke is rosin burning, or resin, resin. You don't want to be breathing that. Now there are different ways of doing this. Some people invest in what's called a Fume Extractor. I just happen to have on my little tool here a little fan to suck air off the area I'm working on. So I'm going to move this back over here. And I'm going to plug that thing back in again. It just runs off USB. Now I would like to take this and put it on this little voltage controller and slow the fan down a bit. Not because it's sucking too much, no. More because of noise. Now I have a little clip here. This wire is always getting in the way. So this thing is sucking air generally this way off the bench. So you can see this. See, it's going in kind of a there. Now another component, some people don't like them. I really like them, and that is what's called the helping hand. Let me just move my components here. Okay. Helping hands. Normally there's 4 more hands on here for 6, but I just prefer 2, so I unscrewed them and took them off. Now I could screw 1 more in and put my fan on it, for example. Let's see. So this is an extra helping hand. So I could do this. Let's see if I can get the screw part tightened. There we go. Now you know how it is. So I have all these. This is all actually scrap solder in the little tray thing. I just don't want to drop it on the floor. Yes, by the way, don't drop your stuff on the floor, because if you step on it, it'll probably hurt. That happens to be scrap. Here's some more of these things. So I'm just going to screw this arm back on. There we go. I just need to see the thread. There we go. So I can go to my fan here, which is on a kind of a flimsy metal one. Now I don't want it blowing, so I got to get the right direction here. I want it the other direction, so Interesting. Every time I grab a hold of that, it vibrates. So I could do this effectively, like so. This is why I want to put a control on it, so that I can actually slow the fan down. Let's put my solder back in here. Okay. Now there are some other tools. On one of the YouTube channels, there's a guy. He lives and breathes by this stuff. Blue tack. To hold his components in place. Now, I like these holding stuff in place. These are flat tipped copper alligator clips. So let's solder some components on. Now, believe it or not, there's a right way and a wrong way to hold the pencil. We are not in kindergarten anymore, so we don't hold the pencil like this. It literally what it sounds like. It's a pencil. So when you hold it as if you were writing. Right? And watch the tip because the tip is hot. So every time you take the pencil out of the stand, check your tip, see if it's shiny. If it's not, tin it up again. So I'm going to put in here, and I can see all the copper, so we're going to put a component down. And I'm going to have to manually control, I think, focus a bit, because this is not going to focus well. So our first component, let's do this capacitor here. This is known as a axial, I think it is. And if it's radial, it's with one end off here and one end off here. So sometimes you see capacitors on board, they're soldered like this with lead on each end. And a lot of times it's a vertical. They're marked. This is negative. Some capacitors have a nice big black negative in it. This one here, you can just see right there and right there two outline of a negative bar. So you would put it in the circuit. Now you're going, well, William, it's tipping over all the time. Well, this is where you have to figure out how you're going to hold the component in. So you can, like I do, oops. See? One alligator clip holding it in. So now if I clip it only in one clip on here, the board has a chance of just moving around. If I put it in two, it's a lot sturdier. So in this case, we solder one. Now we look at our tip, and I'm going to brass it up. It's nice and shiny. And I won't use my scrap, I'll use my new one here, this. So for me, I have to take my glasses off all the time for doing this. Now, I can rotate my helping hand to make it more in orientation of the one. Now, you can see the copper pad here, right there. Now, the trick is not to fill your pencil with lead. That won't work. You'll find later that that causes problems. So you put your pencil on one side of the lead and your solder on the other side. And you just let it go and it flows just like that. So I'm going to just change the zoom so we can look at that a little better, and I have to put my glasses back on again to do this. Now if we shine a light on this, let's see if we can do that. You can see the joint is pretty shiny. Like you can see the shine from the light off it. This is what we want for a joint. Now that we've got one lead in, we can take our copper off and do the other lead. So again, I checked the pencil, it's still good. Any excess, I knock it off. Now, if we look at it again, we see we have another shiny lead. Nice and smooth, little cones. This is what you are aiming for. And then you can clip it off. I would highly suggest you grab the leads as you're clipping so that they don't go all over the place. And have a little, I have this for throwing all the junk in. So there's a cap. Nicely on the board. So let's do something else. Let's do a resistor. I'm just going to clip this back in here for a moment. Now, I like to orientate my resistor. So this is an old school resistor. This is, as you can see, has like 4 color bands, not 5 like the new ones do. So the end here with the gold on it, it's barely seeable. Let's see if I can do this. See that's gold end on the end? I try to orientate my left. If they're going left to right, then I put the values on the left, the tolerance on the right. If they're going vertical, I put the values on the top and the tolerance down. So ideally, if you could use a needle nose, whatever, or just your finger, bend the leads nice and neat. So nice sharp right angle turns. Like this, so that you can place it in the board like so. Now if you don't have a friction fit for it, a lot of people do is when they flip the board over like this, they'll bend the leads outward. Like so. You can see our resistor is sitting there nice and pretty. So then you can put it on the board. And we get our solder out. Now I can look at this, my tin is a little dolly, so now we're back to being shiny again. So now again, pencil on one side of the lead like so. Now once you get one lead side in, you can usually straighten the other lead back out. It just makes it easier. Now you'll notice that there's like a residue there. That's just the rosin. Depending the type of rosin that you're using or what's in it, some of it are water washable and some require a cleaner agent. Well, that's where MG Chemicals comes in. They make all the different types of cleaners and stuff. So again, I'll just clip the leads on these ones. Now you don't want to cut the solder off, so you want to cut just above the solder. So, like so. So that's a resistor. Capacitors, most of them are ceramics are this style. You won't find the capacitor with one lead off and one lead on too often, like radial ones. They're all like this. So we're going to put this one in. Again, I look at the values on this, and I all oriented the values on these. These don't have polarity. So they're not like electrolytics capacitors. Ceramics don't have polarity. So we'll put this in. Now some people will put it all the way down to here, like so. And other people will leave a bit of a gap like this. I'm of technically the preference of getting it straight, like so. And bending the leads. So, like this. See. So, we're going to solder this one. That's in a little. There we go. So, off with my glasses. Now that one solder is done, I'll straighten the one lead out and do it that way. So we can see, again, nice shiny joints, and we can clip them off. If you feel the capacitor, you'll feel it's quite warm. You can feel the heat off it. So imagine that your pencil is way down longer than I have, what they call downtime, right? This can get very, very hot, so watch it. Now, let's say we want to put in our little socket here. Remember I told you these things can melt if you're not careful? So we're going to put this socket in, like so. And this is where I borrow my little alligator clips. Now these particular sockets, these leads on here are flat. They're not round. They're actually flat. So you have to kind of do your copper clip like so. Now I usually use 2 copper clips for doing this. One on one side, and I can see that this copper clip is kind of biting the dust. They don't last forever. So, like so. So then what you do is you solder one lead on one side and one lead on the other side. So in this case, I'm just going to rotate this a little bit so I can do this. And off the old glasses again. So I'm going to do one on one corner and one at the other corner. Just like so. Now I can take the copper clips off. It's not going to go anywhere. And we can finish it off. I usually walk one row and then finish off with the other row. So again, we need to make sure. Sorry, my head's getting in the way on this. This is why you don't want too much solder on building up on the end. You can get what I call joiners, where you join 2 leads inadvertently together, then you don't have to split it apart. But we can see on here now our little socket, nice and neat. Nice and uniform. And nice and even on the board. See? Now this is ready to have a chip put on it. And the chip won't get damaged because you've already got something to prevent that. So, what about LEDs? Well, LEDs are also vulnerable to heat, so you don't want to be your on time too long. I would suggest when you're initially practicing soldering, do it with resistors and ceramic caps. They're cheap, and you can waste a few. So in this case, I'm going to just put a LED in. Now normally, they would have you put it right nice on like that. Now, you can bend the lead, or just grab one of the leads, like so. And I see it's nice and flat. Okay. So I will solder the other one. Pencil's still nice and shiny. Now you have to be quick about this. You can't dawdle. Literally, that short of a time. I was on the lead for no more than maybe a second and a half, 2 seconds. And you can tell that you screwed something up because LEDs are also one of those ones with a plastic shell around it. If you do it too long, right, it's going to melt. And then you'll be just doing it over again with another LED. Luckily, LEDs are a dime a dozen. You can buy tons of them dirt cheap on AliExpress. So there we go, one LED. I'm going to put the other little tinier LED on. I can find it without my glasses. So I have this little tiny LED. Let's put this one on also. So I can squeeze down a little bit with my fingernail. There we go. That puts tension on there so that the leads and the LED are straight. Always examine that. There's nothing worse than assembling something like this and you have a crooked part. Right? I always try to make my stuff cosmetically pleasing. So take the copper leaf off. And we do the other one. So all the trouble with the fan over there. I have a problem getting that. But that's okay. Excess solder gets off on the brass. Let's have a look at this after I put my glasses on. Okay, so manual focus. You can see nice shiny connections. Now we clip them off, so just hold on to the leads into your trash can. There we go. See? You can see how nice and straight they are on the board. Nice and flat. That is an awfully tiny lead. So let us deal with one of our more delicate components. Now this trick I learned about heat sinking the transistor. I actually learned it for a long time ago when I was a kid from another guy. He taught me this because I was having trouble doing these. Might have been actually in school when I first started doing electronics. So let's pick a spot here. So this is what he suggested, these clips initially. So I'm going to take one of these clips. Let's find a nice newer looking one. And I'm just going to put it at the top here, the transistor. Push down on my leads on my transistor. Like so. Come on, cable. And take another thing. I almost don't have to do this. I mean, it's not going to move, but I will do it anyway. So what I'm doing here is I'm trying to make sure my transistor is kind of even, and that there, like so. You might think, well, that takes so much time, William. Well, beauty doesn't come instantly. So again, yep. So we solder one lead. Now, nice thing about this, the heat's going to pass through to the alligator clip. I can take the other one off now. Remember, the bottom one on the other side of the board is all three leads have a heat sink on them at the moment. Okay, let's have a look. I'm manually adjusting focus on the camera off the keyboard here. So you can see all nice joints. We can take this clip off and we can look. Here, let's do it this way. Now that's a nice placed transistor. So then we can clip the leads off. There we go. So now we have here some other parts we can do. Let's do our little, we'll waste a little volume control here. Now, you're probably kind of curious, how do you read these things? Well, see the 205? Let's see if I can make this clear. See that 205? Well, that's telling us, first of all, it's 2NE plus 5 zeros. So 200K, two megohm. Well, in this case, I'm just going to get my scrap piece of paper out and I'm going to write 20 with 5 zeros on the end. 20, 1, 2, 3, 4, 5. So 3. So this is a 2 megohm potentiometer. Adjustable potentiometer. And we just, the spacing between leads in these things, by the way, is referred to as pitch. So these are designed, and this board is a standard pitch size. That's why all these components are fitting on really nicely. So if you get to the point where you actually start making PCBs, you just can't randomly pick hole spacings. It doesn't work. So I'm going to put my little alligator clip on, and I'm going to push down like so, and carefully put it in my clamp. And we're going to do the one lead before removing the clamp. So yeah, we're still shiny. Like so. Now I can remove the clamp. And I can do the other ones. The fan's a bit heavy. I really need it on an independent arm. See how it pulls on the thing? Anyway, now we look at this. Not bad. As we can see, nice placement. Now, come to a component that's completely the opposite of their TO92 transistor here. This regulator. It's designed for heat. Although, if you really get them hot, you will blow them out. So that's why these things have this plate on the back. So either you solder this onto the board like that, onto a big pad, or you have like this one here. See, it's bolted into a big heat sink, and the heat sink is soldered in right here. Big solder joint. So this one is real easy to do. Again, standard pitch sizes. Now, these things also have, see how the lead widens out a bit? It's so you don't push the whole thing down at once. So you can actually line them up like that. So I'm going to get my little copper out again. So I'm going to press with my fingers. So like so. This time I'm just going to put it this way because it's a little easier to solder. Okay. So I will do one lead. Don't need that anymore. But I want to make sure my thing is straight. So I'm just going to have a look. I can see down here it's a little on the crooked side. So I want to do the middle lead first. The leads are so thick that this is hard to get to stay in position because the leads will cause it to flex. So I'm going to do the middle one now. And now I can take the copper off and do the far one. Like so. Put my goggles back on. So now, not bad. Could be a little straighter. But as I usually say, it's good enough for government work. Now these leads, when you cut them, they can go flying all over the place. So do not put your hand over them or grab the leads when you're cutting them. So, like this. Make sure you do this. So now we are good to go. So we put all these parts on. Now we come to the parts that are kind of interesting. Okay, these guys. Now these guys are really vulnerable to heat. So just like the transistor, we got to be careful. But we cannot put a thing up here on this unless you plan to solder them in this way, which is the incorrect way. You don't do this. So you're going to do it this way. Now these guys can twist and turn and everything. So I'm going to find one of my better. There we go. Now, it's always best on these guys to only solder the end pins. If you have a really long row of them, don't do all of them at once. See, I just bumped it. And this has got black gunk on it. There we go. So I'm going to have a look at this before I continue soldering. So I look at this and I can see I got it straight. Good job. Now these guys also can lead you to joining things together, especially if you have a big long row of them. They're kind of like the dip sockets. The pins are such that you can actually do that. So it's important. Now, one of the things that leads to your pencil being down for a long time is it's too cold. Now, I'm running my pencil off my machine at 360. Now, I find that depending on the thickness of the solder and the lead to tin content, I vary between 350 and 375 for solder. In this case, I'm working at 360. So I have another set of leads here. Let's see if I can find my eyeballs. So that was this jumper block. So let's do one of these guys. All right. Now notice these guys, if I can tilt it just right, they have a space there, so you can see the space. There's not much lead coming through the board, and they wobble big time. So make sure you get them nice and snug. So again, I'm going to do one lead and then look at them and then finish off the other ones. Now I don't like that black gunk I have on my solder pencil. That's better. Now this tip is a wedge tip. You can hardly see it, but it's a very, very fine wedge tip. The reason being is if you get the tip that's very pointy, let's see if I have one right here. So I have this one here. See how it's just a point? There's actually not enough heating surface. It's actually very hard to heat something out. You need a flat spot so that you can spread the heat out quicker. The bigger the wedge, the more heat you can spread out. So if you're doing really thick leads, you might want a bigger wedge than I've got. So I can see here that, to my eyes anyway, it's hard to show it on the camera, but one of my leads is a bit crooked. So I'm going to just straighten out this a little bit. It's tilting actually. Now that's correct. Once you get good at soldering, you can usually manipulate things on with hand without putting the pencil down again. But I must tell you, when you're first doing this, don't do that. When I was a kid and I very first learned how to solder, I had more burns on my hand than you can shake a stick at. Because I wasn't used to, and I kept touching the tip or the side, the barrel of the pencil. So be careful. So now we look at this and we can see our little, pretty good, eh? There we go. So these are like a bunch of the very basic components. There are others. I could do different types of capacitors. Not only ceramic, I could do what's called polymer. Something it looks like blue and plasticky. That's another type I could do. There are other components to put on there, like these little edge connectors or pin header connect. These blue things. These are pretty easy to put on, The only thing you run into on these guys is if you get them crooked, like this blue thing could tilt like that or like that. So you have to watch out. And then there's putting heat sinks on. Diodes, like these. Make sure you get your polarity right on these things, the anode versus cathode. This is the same stuff as LED. So we can see tiny little capacitor down there. And we can see little electrolytics. Under here is actually an LED. And then there's a display screws on top right here. You can see it. 2 screws. Right? This rheostat is a 6. You can see the 6 right there. Now this has got 2 wipers in it. So there's 2 tracks in it. A lot of times you'll find these particular potentiometers have 1 track on it, so you only see 3 leads coming off it. But I have actually seen these in 4 and 5 sets, multiple wipers in them. And the wipers themselves, you can actually have these pots where 1 track, let's say, is 1K, and the next track might be 2K. And these guys are usually, it's a carbon track with a wiper on it inside here, which means that when you actually measure resistance on here or do things with it, it's not linear, it's actually logarithmic. Now the type of rheostat that is linear is the wire wrapped ones. If you're old like me and you remember analog joysticks from Commodore days or Apple days, you get that effect in these things where they're wire wrapped and they'll say they're actually 150K complete. So if you turn them back to 50% like this, well, that was 75K guaranteed. So once you're done, I'm going to do one more bit of soldering to show through hole. I have this Arduino, I promised I'd do it. So we have 2 sets of leads. We have this, and we have right angle leads. See, this is a right angle. Okay, so it's kind of interesting on this thing. If you look, and this is where Mr. Pokey device comes in handy, by the way. If you look on these things, see these 4 holes right here? They're actually more pins, but they never supplied a header for them. Right? So they supplied a header for long one, and the right angle one goes off the end here. See, like so. So let's solder on our right angle first. I'll get out my little copper here so I can do this. Okay, now these guys are pretty darn tiny, so so let's check our pencil. Again, I managed to gain some black gunk on it. There we go. So just like the proto board, I'm going to do 1 lead. Since this is plated through holes, I'm going to let the solder flow through it. So it means I have to have an on time of a little bit longer than usual. So that was good. Now where's my solder? I just put it down and I can't find it. Aha. Okay, so we're now going to do the other end. So that's done. Now I could put these things on this way. Okay. Meaning I do, but I want to plug these things into breadboard, so I'm going to do it upside down. I'm going to do it this way. Now with this many pins, you might want to use 2 coppers to hold everything in place. Let's get another one out here. Now this is, I'm looking at it, see if it's straight. Yeah, okay. So all I need to do is really get one in. Like so. So what I'm looking for is, did I make the thing straight? Yep, I did. So now I can do the other side. Just one. I'm going to do all the rest of the pins in a moment. I'm just going to get all of these things lined up and in place first. So let's do the other side. Again. Now there's another trick you can do with this. Actually, I'm going to do this trick with you. So let me just find what we need for this. Okay. We have a breadboard. Another way of lining up all these things is there, just like that. So now you're guaranteed your pins are going to be straight. This is another way of doing these things, if you have a spare breadboard to do it on. Now this is where a problem crops up. I don't know if you just noticed this on this, but I will show it to you. One of our pins is high. Now, getting that pin back down again is a pain in the butt, because what's happened is the breadboard's brand new. Okay. The only downfall of this, if these boards are a bit wimpy, and believe me, there's a lot of knockoffs of these things, with every manufacturer having their own idea how to build them, you get this effect where the first time you put pins into them, they don't go in all the way. But there we go. Now you're saying, well, how do you get this out? Well, that's where this is. Very carefully. This is what happens usually. Yeah, so I screwed up. See how I made an error? Let's see if I can fix this error. Now I have a problem. Yeah, great. I do have a problem. I'll have to fix this pin later. What I'm going to have to do is use my desoldering station and fix this pin. I wonder if I can get it off this way. All I have to do is drag the pin through the plastic though. Okay. So this is the problem part. So if we squish down here, not bad. Okay. A little more. This is why I talked about where these things are very vulnerable to getting heated up and coming out of their plastic. This is a prime example. There we go. So I had to fix it. So now the pin here is the same level as the other pin. Now we leave still 4 more here. A4, A5, A6, and A7. So I happen to have a spare row and I need 4 pins. So that's 3. That's 4. So what we do, I could solder this in, but the problem is if I do it that way on the bottom with the others, what we probably should do is do it this way, because breadboards, the rows are all common. So if you have 5 pins in here, this way is common, this way is not. So I'm just going to get out my little clip again. And the solder. Take our clip out. Perfect. Now we can finish off the bottom ones here. So we will do this. Sorry, my head. Okay, and then I have to do the other end, this end. Okay, so all the bottom pins, these guys here and these guys here, are done. Flip it over and we do the top stuff. And just rotate this a bit. Move my pencil thingy over there. Sorry about the head, but I have to actually see what I'm doing. So, oh, this is, there we go. Since this is hole through soldering, I am holding the pencil a little longer to let the solder flow into the hole. Okay, that's one set done. And my solder's gotten a little too small. So, as you can guess, we need another piece. So I need to flip this around. That one. Let's see, do I actually have focus on that? Yeah, Okay, my solder, our pencil. There we go. Okay, again, sorry for the head. Gotta be careful, there's a very fine little diode on this board here. I can see it. Don't forget too, the heat will pass through the trace and follow the trace along. There we go. So now we built one of these little boards. If you're wondering what this part, oh, yeah, see, hot. I can feel heat on all the pins. So this is a Pro Mini at Mega 168, 16 megahertz. Okay. Now, these are all programmable data pins, this and this. But this, you have to actually use an ISP programmer to actually load the programs into here. As you notice, there's no USB port on this. So this is a variant. I'll get into this when I learn how. Actually, I haven't actually programmed one through this yet, but I should be able to do it. Now you can do this two different ways. Through another Arduino, or you use a serial to TTL converter. But we'll get to that later. So that's that. Now, I haven't used any of the tacky yet. Garbage. Move my garbage can around so that I don't actually empty it out by accident like I did before. Okay, copper things into the center. Alright, let's unplug our little fan. There we go. I'll just unclip it from here. And I'll move this out of here. Put some parts back up on the top. So, where's my mouse? So we've soldered this, and we've soldered a bunch of different components here on a perf board. Now I think I'm going to pick up some perf boards that simulate this. I saw them and they'll be great. So that is really all there is to it. Now there are probably some other stuff you could do with soldering too. You could, if you wanted to clean all the loose resin off, you could clean it with a cleaner, right? I don't usually do that. So after you're done with your pencil and stuff, you know, you want to turn it off and let it cool down. And that really is the soldering tutorial. You should practice a bit. As I said, you know, if you use these things and some random parts like some resistors and these, you can practice putting them on the board. Next bit of tutorial I'm going to talk about is desoldering these parts back off the board. And tricks you can learn to do. Now, I'm not going to get into SMD soldering. I do have the equipment here. But I'm afraid I'm getting old and I shake a bit when I do things. So, and when you're dealing with SMD, they're very tiny parts. It's very easy to breathe wrong and off the desk the part goes. And you're going, what the fuck? And then you have to dig another one out. I suppose that's why when you go to AliExpress, they sell you lots of them at once. just in case the 100 you buy, you lose 99 because you sneezed and blew them off the desk. So, the other thing, if you're like me with where the farther away I look, it's more blurrier. So for me, when I look this close, it's really clear. So that's where having the helping hands and stuff really helps. But if you have to, I'd invest in a lit magnifying glass on an arm or something like that, so you can do it underneath. Now you could go full blown and use a microscope, what Dave at EE Blog or Rosman does. They have these microscopes. So they put the stuff under the microscope and they look through it and they do their soldering underneath it. Right? Hey, I wonder. Oh yeah, that's live. But that's it. That's really the basics of soldering. All I can emphasize is be patient and practice a bit, and you'll get good at it. Anyone can do it. I would presume if you're like really young, your mommy or daddy should supervise you for this. But I'm hoping this is all adult oriented and you are not a kid. But hey, kids, when I was a kid, it was fun. But be prepared. You could burn yourself. So, and that's it. I'm going to post this one and think about the desoldering tutorial.